I don't know if I'm gonna have these intros and outros for every single one of my videos, but there's just a few things I wanted to touch on, so here we are. I mentioned in my last video that one of the main reasons I'm using to back the existence of this channel is the fact that I want to address this issue that I think people will have in the future of people's ability to learn. Well, apparently that future is a little closer than I expected because she said that her students, and again, this is NYU, apparently they exhibit some issues with reading and writing. She says that she gets essays from her students where she reads and just can't understand them. Like she just like literally can't understand what they're writing. And it's as if they just completely missed out on several years of literature classes. So I think I may have a larger potential audience than I initially expected. I don't think that my current method of addressing this problem, i.e. making several hour-long videos of me just talking out loud, is going to be helpful to a lot of people as of right now. But it does make me feel like I'm heading in the right direction. So I just wanted to record this as a sort of log for myself and sort of what I'm thinking about as this channel evolves. After all, this channel is sort of a journal disguised as a YouTube channel currently. And as for this video, I'm definitely still learning how to properly record and film myself. Just honestly, I've been being a little lazy with just messing around with the camera settings and figuring out what the best exposure is and the lighting and angles and all this sort of stuff. But I've been kind of half-assing it because I'd rather like put more effort into just the research side of it. But I mean, it's definitely possible for me to be spending a lot of time just messing around with the camera settings. But I haven't. I will. And kind of same thing with the audio settings. I didn't realize it was an issue until I was editing this video, and I noticed there's a lot of background noise and there's a lot of nasty mouth and breathing noises coming from me. I think this thing was a little close. I mean, even what I just did here probably just made an uncomfortable sound for you guys. But yeah, I mean, I need to figure out something with this and try to make it so that I'm not filling all this footage with just unbearable sounds. And also, I just realized that I need to sort of figure out a way for me to focus on whatever topic I choose a little better. At some point through this recording, I started to like deviate into smart contracts, which I later realized was just like a whole nother topic from what I originally started with, which was blockchains. And yeah, I just need to be able to develop a skill in just recognizing when I'm starting to go down like a completely different topic. And other than that, I would say that I am happier with how this video ended up being. It's definitely still long for what I think is appropriate or like digestible for a normal person. But you know, I think I'll figure out how to make that happen as I keep doing this. So that's it. So yeah, that's it. So without further ado, here's me studying blockchains. Hello, I am Jason Kim, the Clueless Investor, and I think today I'm going to try to answer the question, what is a blockchain? You know, obviously crypto has been kind of a big deal over the last few years, and while I have a very general sense of why that's the case, there are quite a lot of fundamentals about crypto that I just don't fully comprehend just yet. And so I just want to try to clear up some confusion around that and some, I don't know if the right word is obscurities, cloudiness, I don't know. Anyways, the main goal of today is that I'm confidently able to give them an answer. And let me just sort of give a little bit more context. My main goal with this question is to try to understand how crypto works, because while I have like little bits and blurbs of why they work and why people are using them, I don't have like a full picture understanding of what they are. So hopefully by answering this question, what is a blockchain? Just because as far as I'm concerned, or as far as I'm aware, that's a pretty significant part of crypto. Hopefully by answering this question, it leads me to a lot of other good questions that will help me get a better understanding of what this stuff is. So yeah, that's what we're going to be doing today. So I will just begin. And just to start, I am going to just make it simple and ask, what is a blockchain? A blockchain. Okay, a blockchain is basically a special kind of database, but instead of being stored on one computer, it's shared across many computers and designed so that data can't be secretly changed. The simplest way to understand it, it's a chain of blocks. A block is just a bundle of data. For example, transaction records. I'm wondering what other kinds of examples there are. Each block contains the data itself, a timestamp, and a cryptographic fingerprint of the previous block, or a hash. Because each block points to the previous one, they form a chain. If someone tries to change a past block, its fingerprint changes and the entire chain breaks, and everyone can see something was altered. It's stored on many computers at once. So instead of on one central server, like a bank or a company database, copies of the blockchain are kept on thousands of computers called nodes. All nodes need to agree on what the valid version is. This is called consensus. This is why blockchains are called decentralized. Okay, got it. I guess I'll just start writing down questions. You know what? Actually, I will start writing down questions on the right side of my screen. I'm just going to read through the whole thing first. So hopefully that saves me some time. And also, I think it'll just be nice to have all my questions in one place, just so I can kind of see how I'm thinking about things and see maybe in the future if that changes as I continue to do this. So yeah, we will do it this way. So questions. First question I had is, what other kind of data can be stored in a block? How are nodes determined? How is it decided what computers are used to make up the node? Okay, all nodes need to agree on what valid version is. This kind of makes me wonder how this is being determined as valid or not. are the computers just automatically doing that, or I mean, I assume they are. I really doubt that there's just some group of people validating and checking all the different transactions happening, or all, I don't know how to formulate the sentence, all the different ways blockchains are being altered. Never mind, I don't think it's important. No one person can secretly tamper with the data because everyone has a copy. Changing old data breaks chain, and consensus rules reject invalid changes. So the blockchain gives you immutability. Once data is added, it's extremely hard to change. Transparency, anyone can verify the data. Security, it's protected by cryptography and distributed across many nodes. Actually, I don't know what immutability means. Hello, let me ask you this as well. What is a blockchain? And also, let's just use some Google. What is immutability? Immutability is a property of an object or data that cannot be changed after it is created. Okay. Makes sense. Unchanging over time or unable to be changed. Okay. Unchangeable. What it's used for, cryptocurrencies, Bitcoin, Ethereum, store, who owns what, smart contracts, automated programs that run on the blockchain, asset ownership, tokens, NFTs, digital rights, supply chain tracking, decentralized apps or dApps. Okay. I'm just going to take some time to look back through this and make sure that I kind of have a general understanding of what a blockchain is. So blocks are bundles of data, okay? And each block of data contains the data itself, which I don't know what that means, a timestamp, a cryptographic fingerprint of the previous block, which is a hash, and because each block points to the previous one, they form a chain, hence blockchain. If someone tries to change a past block, its fingerprint changes and the entire chain breaks. Everyone can see something was altered. Okay, so that also makes me wonder. So people can try to change the block, change a block. How does that look? I can just manually change information. But it'll just get rejected by the node, or like what if I try to change a block, will I get blacklisted or anything like that? Yeah, I guess I can start with that. I guess I should just throw these questions into here. And while that's answering that, I'll look through what Gemini has to say. Oh, it hasn't, I've never used the deep research part of this, so I didn't realize that I hadn't actually put in the prompt yet. Let's just go through this. What other kind of data can be stored in the block besides transactions? It depends on the blockchain, but in general, a block can include, so for Bitcoin, primarily transaction data, who sent what to whom, a tiny op_return field, which is about 80 bytes, that can store small metadata. People use this for timestamps, small messages, or pointers to external data. Okay. Many questions. I get the transaction data. That makes sense. But this, what exactly do you mean by metadata? And what do you mean by small messages? Because I just don't understand the point of the messages on this. Like, you're doing transactions by messages. Is there like a little mini social media platform going on in here, which I doubt. My best assumption would be that it's more like little memos, like when you write checks or wire people, like you just kind of put in a memo like what this transaction was for. But just for clarification, essentially anything where I read through and I don't completely understand what they're saying, I'm just going to look it up. So like metadata, I have a general understanding of what metadata means, but I don't know exactly what it means in this context. I'm assuming, honestly, that it's talking about this stuff. This stuff is just metadata, but I don't know for sure. So let's just ask. Bitcoin is intentionally limited to keep the chain small and secure. Why is it intentionally kept small? I get secure, and I have a general idea for why it would be kept small, but I want to know the reasoning for sure. So, and on Ethereum, smart contract blockchains, actually, I need to know what is a smart contract, because I know these smart contracts are kind of a big deal, but I don't know exactly what they are. I don't know if I need to keep repeating that. I think honestly, I feel the need to keep repeating that I don't know exactly what things are, because I want to let you know that I know somewhat what they are, because it makes me feel like I look less dumb, but that seems dumb. So I'm gonna try to say that less. Okay, continuing. On Ethereum, smart contract blockchains, much more is possible. Smart contract code, smart contract state, that's ownership records variables. Okay, NFT metadata pointers, usually just URLs or hashes. And what were hashes again? Hashes were like previous data that are like chained to the history of new blocks. I think maybe that's how you might describe that. DeFi data, liquidity pool states, loan data, prices, etc. DeFi, okay. Governance votes, logs, events generated by the contracts. Okay, so I have no idea what any of those are, really, in the context of Ethereum. So there'd be a lot of questions there. Let's just keep reading for now. I mean, I'm gonna need to ask about what all that stuff is. I'll just copy and paste this for now, so I'm gonna ask about it. In general, blockchains don't store files or videos directly. That'd be too big. Instead, they store hashes of files and pointers to off-chain storage, IPFS. Okay. What does it mean by hashes of files? How is this different from just storing files directly? How are nodes determined? Okay, so that's supposed to answer the first question I had. What other kind of data can be stored in a block? Okay. Okay. And then the next one, how are nodes determined? Who decides what computers become nodes? Actually, I'm going to try to organize this information a little more. This can all go under here. So just for the sake of organizing. Okay, and the next question, how are nodes determined? Who decides what computers become nodes? There's no central authority deciding this. Okay, anyone can become a node by downloading the blockchain client software, Bitcoin Core, Ethereum client, and running it on your computer server. The moment you run it, your computer connects to other nodes, downloads the blockchain, verifies all blocks independently. This makes the system decentralized. Participants choose themselves. There are two main types. Full nodes, which store the whole blockchain, verify each block and transaction, and enforce consensus rules. There are mining validator nodes. In proof of work, Bitcoin miners propose new blocks. In proof of stake, Ethereum validators stake ETH and get randomly selected to propose or verify blocks. Anyone can become these two, but you need mining hardware, POW, or mining stakes, POS. Okay, this is a lot of questions. So the first question that comes up for me is if anyone can become a node, does every single node verify every single blockchain, or are they kind of divvied up so that some group of nodes only check for some amount of blockchains and they're just like segmented that way? Or if just like every single computer who downloads this blockchain client software verifies, like becomes a node in this huge mega node of all these computers verifying this stuff, and they all just independently verify every single block that exists. So do nodes verify all blocks in existence, or are they divided into groups that only check a certain amount of blocks? Although with this question, it already seems like it's a bit of both. Like if you're part of a full node, you might verify all blocks, verify every block and transaction. And if you're a mining or validator node, you only propose or verify a certain amount of blocks. This bit is it's confusing. So let's, I should ask about this. Can you explain further on mining and validator nodes? I also just feel like a need to explain part of how I'm feeling as I'm just going about this process. I think the fact that I have so many questions is making me want to withdraw from this, because I'm already starting to feel slightly overwhelmed, because with my previous video with the like options and limit orders and things like that, I was researching something that I had a general understanding of, or like a further general understanding of, things I've experienced with and have heard a lot about. And so there weren't too many questions whenever I read an answer to one of my questions that would come up. It just mostly felt like answers. But with this right now, almost every single thing I read here is new to me. And that is very, that does not feel exciting. And I'm starting to worry already that this is going to be another like 6-hour recording. So I don't know. Let's see. Let's just see first. Let's just get through it. We'll just start with this for now. On this second question. And on the third question, can people try to change a block? What does that look like? Yes, anyone can technically attempt it, but it will fail. How someone would change a block: they modify the data inside a past block locally on their computer. This changes the block's hash. Because blocks are linked, every following block becomes invalid for that chain. Your node will then have a chain that no one else agrees with, is shorter and invalid. What happens then? Your fake modification will be rejected by every other node. Your node will realize your version is invalid and resync to the real chain. You will not be banned, blacklisted, or punished unless you run a validator miner and try to cheat. More below. Basically, changing data on your own computer does nothing to the real network. Okay. That seems pretty straightforward then. Will you get blacklisted if you try to change a block? For a regular user running a full node, no, not at all. Changing a block is simply impossible to propagate because every other node independently verifies the entire chain. Your node will just be wrong and won't be able to sync. Blacklisting only applies to misbehaving miners and validators who propose invalid blocks, nodes that spam the network with nonsense transactions, and validators who violate consensus rules in proof of stake. They can be slashed or lose money. But a normal person manually tampering with data on their own full node doesn't harm anyone, doesn't get broadcast, doesn't get punished, because the network simply ignores invalid data. Okay, cool. Let's see what Google has to say. A technical and strategic examination of blockchain technology defining the distributed cryptographically secured ledger. The foundational concepts and context. The blockchain, at its most fundamental, is a decentralized, immutable ledger of transactions duplicated and distributed across an entire network of computer systems and participants. This technology operates as a full foundational value exchange protocol designed to record transactions in a manner resistant to modification or retroactive alteration. The distributed nature of this ledger ensures that all participants have simultaneous access to the same up-to-date information. What is this arrow? Okay. Defining the blockchain, distributed, immutable, and decentralized ledger. The core characteristics of a blockchain define its utility and resistance to failure. As a decentralized system, it is administered not by a singular entity but by multiple participants, which serves to protect the system from network attacks and mitigates the inherent risk of a single point of vulnerability common in centralized systems. This distributed architecture is crucial, providing resilience and high fault tolerance. The data within a blockchain is organized into a growing list of ordered records referred to as blocks, which are linked together using cryptography. This structural linkage provides a second fundamental property, immutability. Once data is added to the ledger, it is permanently, irreversibly, and transparently recorded, ensuring that the ledger can always be trusted to be accurate. This combination of properties enables the critical function pioneered by blockchain technology, solving the long-standing problem of double spending for digital assets. By creating a single, shared, and cryptographically verified ledger, the system confirms that each unit of value was transferred exactly once, thereby replacing the need for an external, trusted third party such as a bank or government agency with computational and mathematical guarantees. This foundational shift in reliance, moving from institutional trust to algorithmic trust, represents a profound strategic change. The security model is derived from the fact that participants do not need to trust each other, but rather trust the underlying mathematical protocol and the computational power securing it. Okay. It is common practice for industry commentators to use the term blockchain and distributed ledger technology interchangeably. However, a nuanced understanding requires recognizing that blockchain is merely a specific type of DLT. Okay. Oh, okay. DLT is the umbrella term for any decentralized database system where replicated shares and synchronized digital data is spread geographically across many sites or institutions. DLT in general enhances data integrity and transparency through distributed record keeping, allowing for secure and accurate information storage using cryptography. Examples of DLTs that are not blockchains include directed acyclic graph, Hashgraph, and Holochain. The primary architectural distinction lies in the data structure and the sequencing. A blockchain mandates sequential data storage and timestamping, linking blocks chronologically through cryptographic signatures. I was literally just falling asleep. Okay, so blockchain is DLT. A DLT is not necessarily a blockchain. The primary architectural distinction lies in the data structure and sequencing. A blockchain mandates sequential data storage and timestamping, linking blocks chronologically through cryptographic signatures. In contrast, general DLT structures do not necessarily store data sequentially, and the data representation can vary in each ledger. Furthermore, DLT offers broader applications beyond the cryptocurrency focus often associated with blockchain. For example, DLTs like hash graphs are often considered more scalable than typical blockchains because they do not rely on the strict sequential block structure and heavy computational requirements like proof of work. Okay. Wow, I had not a good environment for learning. I had a very good environment for sleeping. This room was very warm and dim, and I was very full when I started recording earlier, and I actually just like fell asleep at my desk. But also, I think that I like basically had like a physiological response to just the stress around trying to figure out how I was gonna go about making a video for this topic again. Because I was seeing all these questions come up and all these questions that seemed like they were just gonna take me deeper and deeper. And I really don't want to have to edit down like several hour-long recordings of myself just talking out loud to find like the points I should even show you guys, because oh, I just like spaced out. I really don't want to do that because it's just, let's just scratch everything I was just saying because I can't really articulate my point. But the point is, I want this to be more manageable for me. And right now, what I'm imagining is a manageable amount of footage is maybe an hour, 2 hours tops. And so that was stressing me out because I just couldn't figure out, like, okay, how am I supposed to know when I pick a topic that I'm going to be able to study it within 2 hours? That just made no sense. Like, all I could do is just pick something that I didn't know or fully understand and then just see how it goes. But I'm realizing that there's no need for me to try to like fully understand the concept in one session. So what I'm going to do instead is I'm just going to research like an hour or two at a time, record that, edit that down, and those will be the videos. Some topics will be multiple parts, some will be one part, and that's just how it'll go. So that's what I'm gonna do. And so to continue, I was reading through Gemini's answer to my prompt, which is just simply, what is a blockchain? And I guess I'll just read through this now. So, this combination of properties enables a critical function pioneered by blockchain technology, solving the long-standing problem of double spending for digital assets. So this double spending thing, I saw it earlier over here. It was saying that it can describe to me how double spending is prevented. I didn't know exactly what that meant earlier, but seeing the way it's worded here, where is it here? Seeing that it's worded like this here, it seems like it's just like a critical characteristic of this blockchain technology. And so my question from that is, I kind of have an idea of why that's important compared to how normal like currency works, like digital currency, US dollars, any country's actual currency. But I don't know how big of a deal it is. So let's ask. Okay. The system confirms that each unit of value was transferred exactly once, thereby replacing the need for external trusted third party, such as a bank or government agency. I know I read this earlier, but I didn't know what exactly the implications of this foundational shift in reliance, moving from institutional trust to algorithmic trust, represents a profound strategic change. The security model is derived from the fact that participants do not need to trust each other, but rather just trust the underlying mathematical protocol and the computational power securing it. Okay, cool, makes sense. I'm assuming this will make more sense once I ask this question. Differentiating blockchain from distributed ledger technology. It is common practice for industry commentators to use the term blockchain and distributed ledger technology interchangeably. However, a nuanced understanding requires recognizing that blockchain is merely a specific type of DLT. DLT is the umbrella term for any decentralized database system where replicated, shared, and synchronized digital data is spread geographically across many sites or institutions. Also, I'm just gonna say, I'm not gonna read everything out loud. Sometimes I just do that just to like be able to focus and get used to saying these things out loud. But sometimes I just focus better when I'm just reading in my head. I will try, assuming it matters, to like remember to hover my mouse over where I'm reading. But if I don't, it's not too important. I'm just reading. I wonder if I need to even know about this DLT stuff. I mean, I guess I do, considering I'm trying to learn what blockchain is, and blockchain is just a kind of DLT. Or maybe I don't. I can't tell right now, just based on what I'm reading. So I guess the double spending problem was one of the main problems that initiated the need for something like a blockchain. Must be important. Okay, so we left off on blacklisting because I was just curious, because it mentioned, or ChatGPT mentioned when it was describing blockchains, that if anyone were to try to change data inside of a block, that data would just simply be invalidated. But that just made me wonder, okay, it just won't work, but what's stopping people from trying other than that fact? Because, sometimes the fact that something just doesn't work doesn't stop people. They'll try to figure things out. And yeah, I guess it's possible to just get completely shut out of the system. Though I guess if someone really wanted to keep trying, actually, I guess none of that matters. Anyways, moving on. Well, you know what? Not obviously. I can't remember exactly what mindset I was in when I left off. So I'm just gonna look through the questions that I have and just go for whichever one piques my curiosity the most. And I think that is these smart contracts, because my dad's been really interested in Ethereum and stablecoins lately, and I know part of the reason that Ethereum stablecoin, like the value and their relationship, sort of has to do with the fact that Ethereum, you can apparently actually do things with it, as some people in this space say. And I think smart contracts are a big part of that, like a big part of Ethereum that makes it valuable. And so, yeah, I'm just gonna look into that, I guess. So I'm just gonna copy and paste this. I'm gonna copy and paste this into here and just ask it to go over this stuff. So I'm curious how smart contracts work and what they are. You mentioned this. What is all this stuff? What is all this stuff? Okay. Without the jargon, thank you. What is a smart contract? A smart contract is basically a program that lives on a blockchain and runs automatically think of it like a vending machine, a bank vault with programmed rules, an app that nobody can delete or secretly modify. Okay, you send data or money to the contract and it executes code exactly as written every time with no human involved. So instead of needing a company, lawyer, bank, or a website, the blockchain itself becomes the backend server.
But what is a blockchain? How do they work? What problems do they solve? And how can they be used?
Okay, so I just had a YouTube video simply explain what a blockchain is, and I understood everything while he was saying it. But now it's a matter of memorizing it. So if someone were to ask me, "Hey Jason, what's a blockchain?" Immediately, I can already tell I'm forgetting things. And I assumed that me just saying this out loud would help me memorize. So I'm just gonna try. Okay. A blockchain is essentially you have a bit of data, which can be things like who owes who what, when it should send, what conditions have to be met for it to be sent, like transaction dates, yeah, like transaction amounts, just all the information for what you need for a transaction with these cryptocurrencies in this case. And anytime a new bit of data is added, it
1991.
Okay, so if I was to be asked what a blockchain is, I would say that a block, okay, in the context of Bitcoin, I guess, a block is essentially a piece of data, or maybe that's not the right. A block is a block is a block, and it contains three things: the data, not the data. Okay, let me restart. If I were to be asked what a blockchain is, I would say, well, a block has three elements to it. One being the data, two being hash, and three being the hash of the previous block. And the data can be things like transaction data, so who sent a coin, who received a coin, when this transaction occurred. And I assume, so there's also things like smart contracts, which can be live on blocks. Either way, it's just data. It has data. And a hash is essentially like a block's identity. It's like a fingerprint. And if you were to change any information inside of a block, it would have to change the fingerprint. And since these blocks contain the hash of the previous block that came before it, if you change one block's hash, i.e. change the contents of it to try to alter information, you have to create a new hash. And once you create that new hash, immediately the blockchain becomes invalid because now that new hash doesn't line up with the hash that was stored in the preceding block. And so in that way, it sort of creates this chain that can't be altered, at least not easily. It's not impossible, but it's essentially impossible, apparently. And one more aspect that makes it pretty much impossible to alter blocks is the fact that this whole system is decentralized, and every blockchain is verified by all the nodes existing inside this blockchain system. And those nodes are essentially just other people's computers. And it's not all held in like one server by one company. It's spread across essentially the entire world now. And all these millions of computers, I assume, have access to this information in these blockchains. And if one person tries to go into any given blockchain and tries to change information inside any given block inside of a blockchain, that's only done on one computer, and every other single computer inside the system will see that altered information and be like, hey, this is wrong. This blockchain is invalid. And it just won't let you change that information. So, okay, I know that a blockchain does that. I know that it's important, like this security of a blockchain is important, but I don't know exactly why it's important. I read the other day that, or yesterday, I read yesterday that it prevents double spending. Yeah, I read that it prevents double spending, but I don't know exactly what double spending is. So, oh crap, I forgot I have this question here. But I'm gonna just ask. I just want to like focus back into blockchains because I was starting to go into what contracts, like smart contracts are, and essentially like how Ethereum works. And while that is useful information for me to know, and it is something that I want to look into, I think it's just going to have me deviate into a whole nother topic. And so right now, just I want to try to focus more on blockchains and why exactly they're important. So double spending is one of the most important concepts in all of cryptocurrency. It's the entire reason Bitcoin and blockchains were invented. Okay, so it's kind of important. Double spending is when someone tries to spend the same digital money twice. With physical cash, this is impossible. If I hand you a $20 bill, I can't also hand that same bill to someone else. But with digital files, duplication is easy. If I send you a PDF, I still have the PDF. If I send you a photo, I still have the photo. Before Bitcoin, digital money had the same problem. Anyone could copy it unless there was a central authority or bank preventing duplicates. So double spending equals duplicating digital money and spending it more than once. Why is this a problem? Because it breaks the entire idea of money. If someone could send 1 Bitcoin to a store, then copy it and send the same 1 Bitcoin to someone else, then the store gets scammed, the money supply becomes infinite, and the currency becomes worthless. Basically, without preventing double spending, digital currency cannot work. So how blockchains prevent double spending? The genius of Bitcoin's design. The blockchain is a public ledger. Every transaction is published publicly on thousands of nodes. If Jason sends 1 Bitcoin to Alice, the network records Jason sent to Alice 1 Bitcoin. Now the entire network knows Jason no longer has that 1 Bitcoin, and only the first valid transaction is accepted. If Jason tries to send the same 1 Bitcoin to Bob afterward, nodes will see, wait, Jason already spent this 1 Bitcoin in an earlier block, so the new transaction is invalid and gets rejected. There's no way to trick the network because every node independently verifies your balance. Okay, this makes me wonder, when is a new block created? A Genesis block, apparently is what they're called. Genesis block. Is it created when a given Bitcoin begins to move, or is it created when a new person starts transacting in Bitcoin? The reason I'm asking this is because I'm just wondering, like, I mean, yeah, I'm trying to figure out when a new blockchain is created, or if it's just like, if a blockchain is created whenever a Bitcoin is first transacted, and then that blockchain just follows every transaction of that one Bitcoin, or if it's based on maybe each individual who's transacting in Bitcoin. So if I have like 100 Bitcoin and I send one to someone, I create a blockchain, and then when I send another Bitcoin to someone else, instead of a new blockchain being created, a new block is added on the current chain that I created with that first transaction. And or if like every transaction and every new Bitcoin, they all create new blockchains and they're all just connected somehow. I don't know if that's important at all for me to know, but it's a question that comes up for me. So I'm gonna write that down. I just watched a video about how does a blockchain work. As you can see up here. And they go over proof of work, and I hadn't seen proof of work or proof of stake in the description ChatGPT gave me yesterday. So let's read through this and see what I understand. To double spend successfully, you would need to rewrite past blocks, build a longer chain, overpower the entire network's computational or economic power. This is nearly impossible because you would need more than 50% of the mining power, POW, or you would need to control enormous amounts of staked tokens, POS. The cost of trying would be astronomical. So blockchains secure digital money without needing banks, governments, or central servers. Simple example, without blockchain, I have $10 digital coins. I send $10 to Amazon, copy the files, send $10 to Target. Both might accept it because nothing stops duplication. With blockchain, I get this. I thought it was going to explain what proof of work was. Why this is the core of crypto. Bitcoin's biggest breakthrough wasn't decentralized or mining, it was creating a system of digital money with no central authority that prevents double spending automatically. This is why transactions don't require banks, the supply can't be inflated at will, ownership is trustless and secure, and cryptocurrencies can actually function as money. I just want to know, what is proof of work, and can you go further? Okay, I'm just gonna copy and paste these into here and just go through. I'm also gonna ask, I'm gonna give this the same prompt as earlier. When and why a new block is created, including the genesis block, how proof of work and purely. Okay. A block is not created when a new person starts using Bitcoin, a specific Bitcoin moves for the first time, a wallet is created, someone buys Bitcoin. None of that creates blocks. A block is created on a schedule, roughly every 10 minutes on Bitcoin. Oh. Why does a block get created? Nodes are constantly collecting pending transactions in the mempool. Miners then gather these transactions, package them into a block, compete to solve a cryptographic puzzle. Whoever wins gets to add the block to the chain. They get paid a block reward plus transaction fees. So a new block is created every 10 minutes no matter what, as long as miners keep mining. If there were 0 transactions, miner would still create a block with only the block reward. What the hell does that mean? What is the Genesis block? The Genesis block is block 0, the very first block ever created by... Oh. Wait, so is everything just on one really long blockchain? So is the entirety of Bitcoin just on a singular, extremely long blockchain? Every single transaction of every single Bitcoin in existence is all on a single blockchain? Oh, interesting. Okay. Oh, that's pretty cool. I'm I'm kind of a fan of like record keeping, and it's kind of interesting just to know that there's just this one essentially logbook, like unchangeable logbook of history of every single transaction that's ever happened with Bitcoin. That's pretty cool. Okay, I see. The other day when I was reading, it said that there's a function in place to keep every block pretty small, and I was kind of wondering what the purpose of that was. I know like storage is an issue, but this makes more sense now. If everything's just on one blockchain and it's currently 600 gigabytes, and people like full nodes download the whole thing, then yeah, I can see this being a problem in the future. Why everything is on one chain? Because Bitcoin is in truth. If there were separate chains, fragmented histories, different ledgers, then balances wouldn't match, double spending would be possible, miners wouldn't ground a state, the currency would break. Okay. Oh, okay. I mean, honestly, this answers a lot of questions I had. Okay, my next question is, how does this work for converting Bitcoin into different currencies? Once a given Bitcoin is converted into something like a US dollar, or actually no. Let me restart this question. How does this blockchain work for converting Bitcoin into different cryptocurrencies? If a given Bitcoin is converted into Ethereum on the blockchain, does it just say one Bitcoin converted into such and such Ethereum, and that's the end of that on the Bitcoin blockchain? And then on the Ethereum blockchain, assuming there's also one Ethereum blockchain, it just shows up as one Bitcoin transacted into such and such Ethereum, and then that goes on from there on the Ethereum blockchain. Bitcoin never took this action. There's no native BTC trend. Oh, okay. I see. Ethereum blockchain only records JSON, where an exchange received Ethereum at Y address. There's no on-chain message like converted BTC into Ethereum, because Bitcoin has no concept of Ethereum. Ethereum has no concept of Bitcoin. They are two completely separate universes. Each chain only knows about its own assets. Okay. When you convert Bitcoin to Ethereum, one of these things is happening. Using a centralized exchange, Coinbase, Binance, etc., is what most people use. What actually happens is you send Bitcoin to the exchange. Bitcoin blockchain says JSON sent Coinbase wallet 0.5 Bitcoin. Exchange adjusts internal database balances, not blockchain, totally off chain. They reduce your Bitcoin balance, they increase your Ethereum balance, you withdraw Ethereum, optional. Ethereum blockchain says Coinbase sent Jason's wallet X Ethereum. Nothing on either chain says converted because the exchange is a middleman. The exchange is doing the swap in their own database, not on the chain. Okay. What is this bit? What happens here? You lock Bitcoin, the corresponding token is minted on Ethereum. Like, okay. Okay, I think I got that. Let's go back up to this double question I asked and see what proof of work and proof of stake are. Also though, I feel like I should, just in case, ask this to Gemini as well. And I'll read back over that later. And just going back to this. Proof of work, the goal of it is decide who gets to add the next block. Miners use computers to solve a hard math puzzle. The puzzle is pointless but hard to compute. The network adjusts difficulty so that a solution takes 10 minutes worldwide. Why it's secure. To cheat, you need more than 50% of the entire world's mining power, billions of dollars in hardware, and immense electricity. Even then, it might fail. What the miner gets, block reward, newly created Bitcoin transaction fees. To rewrite history, you must redo all of the work faster than the rest of the world. Who makes blocks? Miners and validators have chosen. Solve puzzles, random weighted by stake. Resource use, electricity and hardware. Stake tokens, cost to attack. Hardware plus energy, buying huge stake. /diff cheating. Used by Bitcoin, the Ethereum Solana. Environmental costs, high, low, maturity 15 years proven, newer but functional. Okay. I'm a little bit confused on these rewards. Can you just go further into this puzzle thing? I'm having trouble wrapping my head around its relationship to creating new blocks. And also this whole block reward function. Yeah, okay. Okay, so the puzzle is literally just guessing a number until one works. Sounds simple. A hash is a fingerprint of data, always the same length, completely unpredictable. If you change even one bit of the block, the hash becomes totally different. Bitcoin uses SHA-256, which outputs 64 hex characters. The random example is 0.1210 ABC. Okay. Miners are trying to produce a hash like that, one that starts with a lot of zeros. Okay. What exactly goes into the hash? Each block contains a list of transactions, a previous block's hash, a timestamp, a nonce. It's just a number of miners change over and over. miner takes all this data and calculates a hash. Then the miner checks, does this hash start with enough zeros? If no, change the nonce, hash again, check again, millions or billions of times. If yes, boom, they win. They submit a new block. Why zeros? Because a new hash with many zeros is very rare. Okay. Okay, I see. Okay. I think my answer is in this sentence. So you would have to redo all that work. Okay, what I don't understand about this is that it's saying you have to redo all that computing that was done to find any given hash. But why do you have to redo all that work to find out the hash for something that already exists, unless nobody knows what the hash is of any given block? Where does the block reward come in? I've heard recently about this whole like Bitcoin cycle that lasts 4 years, and I'm assuming it has something to do with this then. Before I just continue with this, so every time a new block is created, someone is getting some amount of Bitcoin. Also, does just one person get all that? Does just one person get all that Bitcoin from creating that block? Also, is there a Bitcoin reward for every single time a new block is created? I asked that last question because, like, I know there's a limited amount of Bitcoin that can exist, and I mean, what if every 10 minutes a new block is created and someone gets a Bitcoin, then, you know, there's a certain amount of time when no one can get any more Bitcoin. Okay. Oh, mining pool, yeah. I need to ask what these fees are. Yeah. Oh, every transaction the block has a fee. Miner get to keep some of all the fees. Example log, 0.8 Bitcoin worth of fees, including common during busy periods plus. Oh, okay. Okay, so, I mean, so I think a very obvious question from here is, what happens when all Bitcoin is mined? They just keep creating blocks. There's no longer a Bitcoin reward. Miners only get fees, and blocks just keep tracking data. And are the transaction fees just the fees from every single transaction that happens of Bitcoins in any 10-minute period? Okay. Okay. Oh. Okay. I gotta go. I'm gonna leave it at this for now. This was helpful. I don't know if my next video should be just continuing off of this or something else. I think I'm gonna settle on that as I edit, but we'll see. Either way, thanks for watching. I am Jason Kim, the Clueless Investor, and that's it. Bye.